Hello everyone, and welcome to Linux Forensics here at Pentester Academy. In this video, we're going to talk about some first steps once you have an image that you are ready to mount. So I have an image that I captured to an external drive. I'm going to go ahead and plug in my external drive. And then I'm going to use a script from a previous video in order to mount it. So one of my scripts is called mount_image.py, and I'm going to run it as root. And the image I want to mount is on my external drive, and it is here. So I'll go ahead and mount that, and it told me looks like it's an MBR, and it found a bootable partition type 83, which is Linux, and it also found an extended partition, and it warned me, and it said that this script doesn't support those, but we did have a script for that. Now, if I actually ran that script, it won't do anything in this case. And the reason for that is that this extended partition is nothing but a swap partition. So if I go ahead and rerun it, sure enough, it comes up and it says, I am skipping that swap partition. If I run a mount command, I can see right here at the bottom that I've mounted onto media part 0 an ext4 file system read-only with no access time updates, which is what I wanted. Great, so now I'm ready to do some work. In a previous video, we talked about how you could create a timeline using some commands while doing live analysis. Recall that we talked about using the find command and some of its parameters in order to create some Mac time files that we then sent over the network. Well, we can do something very similar using a script here. So I've created a pretty simple script. Here it is. Starts out with shebang bin bash, a usage function. It takes one parameter, the starting directory. And again, why does it have a starting directory? It has a starting directory because you might not want to do all of it. It might take a little while for this to run. If you don't pass in enough parameters, then I call usage. And here's what I do. I first capture the current directory. And the reason I do this is if you look at the generated file, if I don't change to the root directory for my image, I'm going to have a path prepended to all of my file names, which is not what I want. So I change to the appropriate directory. I then print a header, and I'm using semicolons to delimit each of my values. So I put out access date, time, modified date, time, creation date, time, etc. Then I use my find command on the current directory, and for every file that I find, I print out all of these things. And these things were covered in a previous video. When I'm done, I cd to my old directory. So I can go ahead and run this. and I'm going to run it, and it's called get max, and I'm going to run it on media part 0, and I'm going to redirect the output to media fill, Toshiba, disk images 2015 3.9, and I want this to be max. Or actually, I'm going to call this one CSV. And it runs. It'll take just a little bit of time. And this is one of those things where it will run a lot faster if you have a USB 3 drive. If you're running a USB 2 drive, even the simple command will take quite a while because it's having to essentially do an ls recursively through the entire file system. And that's done now. Well, that's all for this video. As always, if you're enjoying these videos here at Pentester Academy, please tell a friend and help us spread the word. We'll see you soon. Hello everyone, and welcome to Linux Forensics here at Pentester Academy. In this video, we're going to talk about some first steps once you have an image that you are ready to mount. So I have CSV. I can now run up something such as LibreOffice Calc, and I can import this file. So I'm going to go ahead and start LibreOffice Calc, and then I'm going to show you how you can use this in order to import this CSV file. Now, this will take a little bit of time, but I'm going to go ahead and open this file. And the file is on media, fill, Toshiba, disk images, and it's this CSV file. We see that it's 29.3 megabytes long. And it will ask me what kind of thing is it? Is it UTF? Is it ASCII? Is it whatever? And it's probably safe to leave it as UTF. And it asks, where do you want to start importing? Do you want to skip any rows? I don't. And everything is separated by a semicolon. And it gives me a little preview here of what I will get. So I'll go ahead and click OK. And it's going to go off and do its thing. So why would I want to do this? There are some other options. You could use a tool like Autopsy in order to generate what's called a body file from this information, from this image, and then use another tool in Autopsy called MacTime in order to generate a timeline. You can certainly do this. It's something that I've done before. One thing I like about this idea and this way of doing it is I have a spreadsheet, and the spreadsheet is very easily sorted in various ways. So here I have all this metadata on all of my files. So for example, maybe I want to see the access dates and times, and I want to sort based on that. Well, there are a couple of ways that I can do that. Now, one thing I might need to do is I might need to make sure that it is treating the dates as dates in LibreOffice Calc or OpenOffice. Either one will work. So if I select a column and I go to Format Cells, and I'm actually going to select the entire column, and then I'm going to click on Control-click on the first header and say format cells. And I'm going to make sure that this says date. Now you can pick the kind of date that you would like. I'm going to go ahead and sort them this way. Pick whatever you prefer. And now that's been changed. The same thing I can do with the times. The times have fractional seconds. And maybe I don't want to display all that. So I'll control click, right click, format cells. This is a time. I'm going to use military time. And I will adjust this date as well. This is a date. We'll use the same format throughout. And here's our last time. So now this should be a little bit easier to sort. So now that I've got all of that fixed, I can go ahead and select my columns. And now I am going to go to Data, Sort, and I'm going to say I would like to sort this on first access date and then access time. I can further sort by file name in case there's a tie. I'll click OK, and this will take a little bit of time. And there you have it. Now I have all of my access dates. I could have also sorted them descending, and I'm going to show you how long this takes. I'm just going to go ahead and redo that. I'm going to go to Data, Sort, Descending. This way I can get the most recent activity at the top. And you see here some of the more recent activity. And of particular note, I see that this user John downloaded a utility here, Xinxi Quan. And if I know anything about that, I should know that that is in fact a rootkit. And I can see that this file was accessed several times. Also, about that time, there were some library files that were accessed. And some of those library files are likely needed in order to compile this rootkit. So here we see a whole bunch of them that were accessed. So it's another example of what happened with our compromise. Well, that's all for this video. As always, if you're enjoying these videos here at Pen Tester Academy, please tell a friend. We'll see you soon. Hello, everyone. Welcome to Linux Forensics here at Pen Tester Academy. In this video, I wanted to talk about how you might integrate MySQL into your forensics investigation. Now, the first question you might have is, why do I want to do this? Well, if you look at some previous videos, we talked about how you could create a CSV file, for example, to use to build a timeline. And that's great. If you have a CSV file, you can put it into your spreadsheet and you can sort it all different ways. You can sort it by access times, modification times, or creation times. And that's very convenient. Sometimes you might want to look at very large volumes. Our example is fairly small. It's less than 20 gigabytes. So it took a little bit of time to sort through that. But if you had something where you have millions and millions of files, it might take a really long time in order to operate with that inside your spreadsheet. So if you want to optimize that a little bit, you could use a database. So MySQL is pretty simple. If it's not already installed, you can install it with sudo apt-get install mysql-server. And in my case, it will tell me you already have it. Once you've installed MySQL, you need to create a database. And that's pretty easily done with MySQL admin create, and then you can give it the name of your database. Say case 2015-3-9. Now it told me that it failed, and the reason that it failed is I neglected to give MySQL a password. So by the way, when you install MySQL, it will prompt you for things like this. So I will give it -u root -p for please ask me for a password. So I will give it the correct password, and it's done. I've created a database. The next thing I need to do is I need to actually log on to this database. So if I type MySQL -u root -p, it will ask me for my password, and I can type connect and the name of my database, case 2015-3-9, and it says you're connected. So the first thing I want to do is import all of my information from the CSV file. So how can I do that? Well, I wrote some pretty simple SQL. Now, there's a couple ways you could go here. To keep it simple, I wrote some SQL in a file, and I'm just going to copy and paste it into MySQL. And this allows me to do things like change file names. So the first thing I want to do is create a table called files. So I'll create a table. I'm going to copy this. I'm going to go back to MySQL. And I'm going to paste it. And it says 0 rows affected, which is correct for creating the table. There's nothing in it yet. So if I go back now to my editor, I can run this command. Now, this command, load data in file, is really useful in MySQL. A couple of things you should know. You must have the file in an approved directory. And this is a security thing that's set up in MySQL. Now, if you want to work really hard, you can go into the config file and you can change this. Or if you're feeling somewhat lazy, you can do what I did and throw it into temp, which is normally an approved place. So you can copy your CSV file to temp, and then you call load data in file and give it the file name. and put it into your table files and tell it my fields are terminated by a semicolon. That's how I set up my script before. They're enclosed by double quotes, and the lines are terminated by \n. I've also said please ignore the first row, because the first row just had the header information that labeled the different columns. Now, if it was a simple table, I would be done. However, I have a bunch of dates, and those dates have to get converted. And there's a function called stir to date that I have to call. So this makes this SQL statement a little bit more complicated because I have to do this. I have to list out explicitly each column. If I didn't need to change anything, I wouldn't have to do this. And we'll see an example of that a little later. So here I am, and I need to put in at access date, and then access time, at modify date, modify time, at create date, create time, etc. And then I have this set statement. I said set access date equal to stir to date of this value here. Now I was capturing this value, and my strings are in this format, kind of the standard US format, if you will. Month, date, and 4-digit year. And the same thing is true for the other two dates. So if I copy this and I go ahead and paste it into my terminal, it will import all of that data, which will take just a little bit, and it tells me it just imported 184,601 rows. And it took 6.37 seconds. Not too bad. So I can do some simple queries. Probably the simplest one would be something like this. Select star from files, order by access date, access time, and if I want it descending, I say DESC, semicolon, and it'll take just a couple seconds, and here I have my information. Now, in my case, this is just scrolling by, but I could pretty easily save this to a file. And we'll talk more about that in a future video. Well, that's all for this video. As always, if you're enjoying these videos here at Pen Tester Academy, please tell a friend. We'll see you soon. Hello, everyone, and welcome to Linux Forensics here at Pen Tester Academy. In this video, we're going to continue our discussion of how you could use MySQL in order to speed up some of the things you might do in your forensics investigations. So in the previous video, we showed you how to create a table called files, and we had all that metadata that we created from a script after we mounted our image, and we showed you how to do some very basic queries with that after you loaded it in. Now, another thing that you might want to load is the password file. So I have a script here. It creates a users table, and this users table essentially has all of the fields from my password file. So I'm going to copy this. I'm going to go here, paste it, And I've created the user table. Now I can load it. How do I load this table? Well, this table is already in a delimited file. It's in the password file. This one is colon delimited instead of semicolon delimited. So if I go back here, what I've done is I went ahead and I copied my password file and also my group file to my temp directory, and I'm going to call load data in file. What I'm going to do is load the data from the file temp password into the table users. The fields are terminated by colons now, and they're enclosed by double quotes, and the lines are terminated by new lines. Notice I don't have to do anything near as complicated as I did with the files table. So I will take that, copy it, go back to my SQL, and paste it. And boom, that's done. That happened in well under a second. I can select all those rows. And here you can see my various users. Now, there are a couple reasons that I might want to do this. I want to see things like people's login shells, their home directories, but the other thing that I might like to use this information for is to correlate a user ID to a username. And I'll show you how you can do that with some queries in a little bit. So before I do that, I wanted to show you how I can go and import the groups. So I create a table called groups, and it reads the group file. And it has a group name, password hash, a group ID, and then a list of users in each group. So let me create that table. I'll copy here and paste. That's done. And I can go back and load it. And again, I've copied this from my image, which I mounted, to my temp directory. Copy here and paste once again. And now I have 66 rows. So I have more groups than I have users in this case. So now, if I want to look at some files, I could run my query and I could do something like this. I could say select access date, access time, my file name, my permissions, and I want the user who owns the file. So I can say I want the username, and I'm going to select this from files and from users where files dot user ID equals users dot UID. I want to order by access date, access time, descending, which is actually just DESC. I put in my semicolon. It'll take a couple seconds for this to run. But now I have a printout where instead of having a bunch of numbers for my users, I in fact have a username. And of course, many of these files are owned by root. I could actually check and say, where this is true and files dot user ID not equal to 0. And I get a lot less. And depending on the situation, this might tell me more. So here I see light DM, color D, and some other things that are happening. I see lots of files. I see lots of files that are owned by John, which makes sense. He seems to be the primary user on the system, etc. Again, why bother? The nice thing about putting this into a database is that your queries tend to be very fast, but they can also be very flexible. Now, sometimes I'm a little bit old school and I like to do queries in actual SQL and even in the MySQL client. You don't have to do that. You can always use a tool like PHP admin or anything else that you prefer in order to do these queries. Now, here's what I do like about it. I like the flexibility. Here's a good example. Just today in one of my classes at the university, I had some students working on a project. A commercial tool wasn't working because of some technical glitches in the lab, and we had to use Autopsy to complete this assignment. Now, Autopsy has a lot of nice views into your data, but it has a limited set. So, if you have something like this where you've put your data into a database, this will allow you to be extremely flexible. So, for example, Autopsy will allow you to say, I only want to look at files of a certain type, or I only want to look at files of a certain size. If I have this in a database, it is very simple to do both of these things. And that's what makes this very powerful. Again, this is optional. You don't have to do this. You don't even have to make the CSV files and look at it in a spreadsheet. I just find it very useful. Well, that's all for this video. As always, if you're enjoying these videos here at Pen Tester Academy, tell a friend and help us spread the word. Realize that the more people that subscribe, the more videos we are able to provide to you. See you soon. Hello everyone, and welcome to Linux Forensics here at Pen Tester Academy. In this video, I'm going to show you how you can add a very simple timeline table to your database, and this will allow you to create some very good reports of your timeline. Earlier we showed you how you could create a report that showed you when everything was modified, when everything was accessed, and when everything was changed separately. So here I'm going to show you a really simple way that you can combine all of that information into one central place. So what I have here is a very simple script. And this script actually is a shell script that is primarily a SQL script. So we start out with shebang, bin bash, and we have our standard usage method defined. And in this case, I only want a database. That's the only parameter I want. And it will go into that database that I've already created, and it will allow me to set up a new table from my files table that I can use for timeline generation. So if you give me less than one parameter, I give you the usage. Otherwise, I run this script, and this is what the script does. Here I have a construct where I say cat less than EOF, and what this does is it will cat from here until a line that starts with EOF, and I'm going to cat all of this stuff here and pipe that to MySQL. So here I'm going to run MySQL, and the first parameter I'm going to pass to it is the name of the database that you passed into the script, and I'm going to say, please log in as the root user and prompt me for a password. The first thing that I'm going to do is I'm going to create a table called timeline, and it's going to start with one character for an operation, either access, modified, or created. Incidentally, I should point out that for a Linux file system, there is no such thing as a create date. What we are really saying is a create date is an inode change date. That's something to keep in mind when we look at Linux file systems, that it's a little bit different from Windows. Then I have a date to go with that operation, a time to go with that operation, and then a record number. Now, record number is going to be a key into my files table. So the files table, I created an auto increment primary key. So every time you put something into that table, it creates a number. And the reason I did this is to make this a lot faster. It also makes your tables not so redundant. If you do a lot of database work, you talk about things like third normal form, which we really don't care about here, but we do want it to be reasonably fast. First, create the table, and then I insert into the table everything from the files table that involved an access date and time, everything that involved a modification date and time, and everything that involved an inode change or creation date, if you will, event. I insert those three things into the table, and what that allows me to do is more easily create a report that's linear, and it has the access, modification, and creation all intermixed. So I can go ahead and run this. If I go out to a command prompt, it's pretty simple to do this. So I will go ahead and run my script, which was called create timeline.sh. I will give it my database, case 2015-39. It'll prompt me for a password, and then off it goes. It should create my new timeline table for me, and that's done. Now, how do I use it? Well, it's pretty easy to use this in a query, and I've actually gone ahead and created another simple script that will allow you to print out a timeline. And it works by taking the database again and also a starting date. That way you can say, I think this incident occurred around this date, and this can prevent you from having to go all the way back to the beginning of time. You might have some things that were created years ago, and that's probably uninteresting to your investigation. Now, of course, we'll talk later in this course about how these things could all have been faked, but this can be a good starting point. So if I look at this script, it says shebang bin bash, a little usage, and I check to make sure that you've passed me enough parameters, and I again build a SQL statement. In this case, I use the same construct, cat less than EOF, pipe that to MySQL, and I select operation, timeline, date, timeline time, file name, permissions, user ID, group ID from files and timeline where the timeline date is greater than or equal to the date you passed in. So the date you passed in, I send to stir to date, and here's what you passed in, and here's the format I expect. If you prefer another format, feel free to change that. And also, we need the record number to match between the two tables. We need to join them together, and I will order this by the timeline date and the timeline time descending. So that way the most recent stuff appears at the top. So if I were to run this, what will I get? So I'm going to say print timeline sh case 2015 3-9, and I will give it a start date of March 1st, 2015. Ask me for my database password, and off it goes. So now I have my report, which normally I would want to capture to a file, which I in fact have done, and we will look at this file in the next video and do a little bit more investigation as to what happened to this workstation. Well, that's all for this video. As always, if you're enjoying these videos here at Pen Tester Academy, please tell a friend and help us spread the word. We'll see you soon. Hello everyone, and welcome to Linux Forensics here at Pen Tester Academy. In this video, we're going to look at the timeline that we stored in a database in a previous video. So here I wrote another simple script. You don't really need to use this, but it might make it easier for you to look at your timeline that's in the database. And what I did here is the script will take the name of the database and a starting date, and then it will do a simple query. It will print out your timeline showing all the different modify, accessed, and changed operations from your timeline, starting with the date that you give it. So let's go ahead and run it. And I will go ahead and run print timeline sh on my database case 2015 3-9. And I will start at March 1st, 2015. It'll ask me for my database password, and off it goes. It's going to create this. Now, normally you would want to capture this to a file, which is something that I've already done. And we will look at this in our editor in just a second. Similar to what we've done in some other cases, you could create a CSV file of some sort and put this into a spreadsheet if you prefer. That's a pretty easy modification to do to our simple little script. But for now, I'm going to look at the text file that I generated. And here it is. Now we sort this file from the latest times onward, previously we said that this user had downloaded a rootkit. So I'm going to go ahead and search for Xing. It was Xing Shi Quan that he had downloaded. Now, this is on the 12th. There was some activity with this file. Let's zoom ahead. Notice there are 270 occurrences, and I'm actually going to search back from the first one. And I see I'm getting some false positives. But here is my first real deal. So if I look at this entry in my log, I see that on the 5th of March at around 11 o'clock in the evening, there was a modification made to this file. Most likely what that means is this file was modified at that time because it was downloaded and then put into this directory. So here we have this tar gzipped file, and I'm sure if we look a little bit later we will start seeing some other accesses to this file. So if we search upward, here we see a create or change. So again, a change in this case means a change to the inode. And here I see some other things happening about a minute later. So it looks like about a minute after this file was downloaded, this rootkit was uncompressed and likely installed. So here it's been uncompressed. Let's see, maybe it took whoever the attacker was a little bit of time in order to figure out what to do with it. So I'm going to start here. I'm going to search upward. And I see that a few days later, actually, so apparently our attacker didn't really know what to do with his new rootkit. He must have logged back in and he read the README file. I see that more was used, so he must have used more in order to look at the file. Then I see these files being accessed again. And what else do we see? We see a bunch of accesses to some other files, and I see a access to a reverse shell. So it would appear as though this rootkit has now been installed. All right, so yes, it looks like the user John had something to do with this compromise. Now, this doesn't necessarily mean that John was behind it, but it does appear as though around the 5th of March, someone used the John account, they downloaded a rootkit, and they installed it a few days later. And it appears as though it's been installed ever since. Now, one of the things you will see if you look a little further into this rootkit, you will see a bunch of entries for where this rootkit directory is continuously accessed. Now recall that when we did our netstat and we looked at what ports were active, we did an LSOF to look at open files and ports, that failed. And it was probably because of this rootkit. And we'll see in some later videos if we could possibly get that information back using some memory analysis. So again, what's happening here is most likely that this rootkit is covering its tracks every time it gets run. And here you see all of these source files that are being included when this is built. So if you look under user include, user lib, you might also see some stuff from user source where it's getting various binaries in order to install itself. In fact, right here we have our install command. So that user ran the install command, which then called gcc, and that accessed all of these header files in order to build our rootkit. Well, that's all for this video. As always, if you're enjoying these videos here at Pen Tester Academy, please tell a friend. We'll see you soon. Hello everyone, and welcome to Linux Forensics here at Pen Tester Academy. In this video, I'm going to show you a simple script that you can use in order to extract the user history files from your image. It's similar to something we did previously with our live response, and here we just want to do the same thing and extract our image into a CSV file and optionally into the database. So how does that go? Well, here's our script. It starts out with shebang, bin bash. There's a usage, and the usage says, hey, this is a simple script to get the user histories and optionally store them in the database. How does it work? You give it the mount point of your root directory for your mounted subject system. Of course, it's mounted read-only using a script that we have from earlier. And if you give it a database name, it will try to import this information to the database as well. If you don't give me enough arguments, I give you the usage. So I first save the current directory, then I will change to my mounted directory for my subject file system. This is to avoid having the local mount point prefaced onto each entry for the file names. So if it's mounted under media part 0, for example, I don't want that in all of my file names. So I will find in the home directories, only files please, and here's my regular expression. My regular expression says I want something under home that's a username, which is consisted of these characters and one or more of them. And then I have bash history. If I find such a file, I will exec awk on that file. So awk, I have my awk command right here, and my awk command says print out the name of the file, semicolon, and then print out that line from the file. And remember that the empty curly brackets is the name of the file. So this prints the file name, and then it prints out a semicolon, and then whatever is on each line of the file. This semicolon ends that exec command, and then I pipe this to T, and what T does is it T's the output to both the screen and to a file. And I store this in temp history CSV. I do the exact same thing for the root user. And notice that for the root user, I give T a -A option, which says, please just append to this file, don't overwrite it. Otherwise, you would have just the root user's bash history if it exists at all. I then change back to your old directory for you. Now, if you gave me a database name, then I will first of all change the ownership on this file to MySQL. And the reason I do this, I found that sometimes you have trouble importing the file if MySQL doesn't own it. It will actually give you an error saying I can't read the file or I can't find the file when it's very clearly there. Then I use my construct, my cat less than EOF. So I take all of this stuff between here and EOF, and I pipe that to MySQL. I connect to whichever database you told me as root, and I prompt you for a password. I first create a table, and then I will load it. I call load data in file, which we've used in the past. And this one is pretty simple. There's no dates or anything complicated that need to get converted. Here's my end of file, so that's the end of my cat, and here's the end of my if statement. So that is fairly simple. Let's go ahead and run it. So I'll go to my command prompt. Some of these commands I'll need to run as root. And the first thing I need to do is I need to mount my image, which was stored under media, fill, Toshiba, disk images, 2015. .39 IMG, and sure enough, it's been mounted. In fact, it's even come up here in my file browser. Go ahead and I'll close that. And I can verify that it was successfully mounted using mount. And I see here it is, mounted read-only, no access time, updating. And it was ext4. So now I will go ahead and run my script. So it's get histories. I've mounted this at media part 0, and I will connect to my database case 2015-39. It does its thing, and now prompts me for my database password, and it does what it's supposed to in the database. And if I go to my database, I can see there's a new table called histories, and I can do a select from it. And I have 250 rows. Well, that's all for this video. As always, if you're enjoying these videos, please tell a friend. We'll see you soon. Hello everyone, and welcome to Linux Forensics here at Pentester Academy. In this video, we're going to examine some of those user history files that we collected in a previous video. So I've run my script, which I already showed you, and now I have a CSV file. And I've opened up LibreOffice, and I want to go ahead and import it. So I will click on my Histories CSV, and it will ask me what separates my fields, and they are separated by semicolons. And it gives me a preview. Everything looks okay. So I'm going to go ahead and click on OK, and I will have a look at what sort of things this user John was doing. Now, as a reminder, the John user account was somehow involved in this compromise. We're not saying that John was personally involved, just that his account was used. We can look at what kind of commands have been run from that account and from other accounts as well. So here we have John's history. Now, one thing to keep in mind, unfortunately, we don't have timestamps on these commands. We just know that they were run at some point in the past. And it looks like he did some fairly typical things. He updated his system, he installed a few utilities, and here he installed Chromium, and apparently he must have used that in order to download this tool. We don't know that for certain. So he changed to the Xing Shi Quan directory, and he untarred the file. So this must have been sometime around the 5th or maybe the 9th when he came back. And what else happened? The rest of this here looks like normal user stuff. He ran an if config command, again, not necessarily unusual. Looks like he was searching for some sort of media. And he must have mounted something and performed a few commands. Again, none of this looks suspicious. In fact, you might recognize some of these commands as being used in our live response, which we did from this John account, which was, if this were an actual case, kind of a bad thing to do. All right, so now we get to some interesting things. So John ran user add on John with 2 N's. So this is something we saw previously in our modified files timeline. Then he deleted that and added it back. Most likely what happened here is that he was creating a new account, hoping to be stealthy, and he used the wrong add command for a user. He used the one that is expecting a bunch of parameters, which he probably didn't remember. So he just deleted the account and added it back. So we don't look like we have a very sophisticated attacker here. And this is kind of interesting. He copied bin true to bin false. Now, we know that we had some interesting things where it would pop up with messages saying there were system troubles, etc. And this could cause those kinds of messages. If you have a program calling bin false and it returns true, that might mess you up. The other thing to notice here is that bin false is often used as a shell for users that should never be allowed to log in. So perhaps this was an attempt to allow people to log in. Here he does an ls-l on bin false. He sets a password for the user whoopsie and for the user lightdm. This is a little bit odd because normally these users should not be allowed to log in. And at some point he copied bin bash to bin false. So again, it doesn't sound like a very sophisticated user. Probably what he did is he thought, I'm going to copy bin true, and that's going to let me log in. Maybe he tried it, and it didn't work. Now you might say, well, where's the history of him trying it? He didn't necessarily try to SU from John's account to do this. He might have tried to log in remotely, for example. Again, recall that this system has FTP and SSH installed because it's needed by the developer. So he's doing a VI on a file, Looks like he screwed it up. Tried it again. Went to Etsy. Said, what was that file called? He catted out the password file for some reason. Changed his home directory, did an ls. And then he moved John to .john in order to hide that directory. Went back to the password file, did a man on sed, tried a sed command, apparently it didn't work. Tried another sed command where he tried to change John, it looks like, to .john. He did a tail on the password file in order to see if that was successful. He ran install, probably for this rootkit. Then he ran nmap to see if it was detected. Change directories, a couple ls commands. Changed to his downloads directory, and again did some ls commands. So I suspect that he changed to his downloads directory to see if that rootkit was still visible after being installed. Also checking out his other directories, looking to see, hey, can I see that file for my new home directory? If I can't, let's try ls-a, which probably did display it. Clear the screen, and some point later, back at Xinshi Quan, looking at the README file. Perhaps he had to reinstall this for some reason. Did an nmap on localhost. And let's see if there's anything else interesting. The rest of these commands look an awful lot like things that we did during our live response. Probably was not a great idea to use this John account. We probably should have, maybe used the root account or some other account. It just randomly happened that we used the account that was involved in the compromise. So that was not a very good practice for our live response. But here you can see all of our commands that we performed as part of our live response. So from this point onward, it's likely not terribly interesting. What about this new John user? Well, here I see he did a W to see who was logged in and what they were doing. He did a cat of the password file, and he became whoopsie, and he became light DM. Now again, these are two users that don't normally get to log in. So he was probably testing out some of the things that he had done. Well, that's all for this video. As always, if you're enjoying these videos here at Pen Tester Academy, please tell a friend. We'll see you soon. Hello everyone, and welcome to Linux Forensics here at Pen Tester Academy. In this video, we're going to show you how you can extract log files from your image and optionally import them into a database. What I have here is a simple script, and this script, like most of the scripts we have, starts out shebang, bin bash. I have a little usage function which tells you, please give me the mount point for the root directory of your subject file system, and give me a database name if you want me to store this in the database when I'm done. If you didn't give me enough parameters, I'm going to give you the usage, I start out by saving the current directory, and then I change to the var directory for our subject system. I use our old friend find, and I find under log, again that's var log, files that are actual files. I'm going to use a regular expression, and here's my regular expression. My regular expression is, look under log, look for something with letters, possibly a dot, one or more of those, and then look for 0 or more letters and then a dot. So you're looking for something that is an actual log file. If you find it, exec awk, and here's my awk command. My awk command says, please print out the name of the file, semicolon, and then whatever was on each line. And remember that the empty curly brackets is going to be used in order to replace this with my file name. So if my file name was, let's say, syslog, it's going to print syslog, semicolon, and then each line in that file. I will also pipe that to T, which T's the output to the screen into a file. So I'm going to, in the background, capture this to temp logfiles.csv, and then I change back to your old directory. If you gave me a database, then I will change ownership on this log files CSV file. The reason I do that is to avoid problems importing it into MySQL. I use my cat less than EOF construct that we've used before. So I'm going to pipe to MySQL all of this. So from here to the EOF, I create a logs table, and I give it an entry for a log file name, a log entry, and I give it a big int that it is auto-incremented, which is a key. This allows me to more quickly access my database should I need to. And it's really optional, actually, in this case, but it's a good habit to get into. So here, I load data from my file using load data in file into my table logs, and this is another very simple import. I tell it my fields are terminated by semicolons, and they're possibly enclosed by quotes, and the lines are terminated with new lines. And then here's the end of my if statement. So pretty simple. If I run this, so if I go out to my command prompt and I run get logfiles.sh on media part 0, then I give it my database case 2015-39, and it should go do its thing. And it's done. So in a future video, we will have a look at our log files. But that's all for this video. As always, if you're enjoying these videos here at Pentester Academy, please tell a friend. We'll see you soon. Hello everyone. and welcome to Linux Forensics here at Pentester Academy. In this video, we're going to show you how to examine some of those log files that you captured in an earlier video. So I've already logged in to my MySQL database. And as a reminder, if I do a show tables, I will see that I have a logs table. So I can go ahead and describe my logs table. And it shows me it's pretty simple. It has the file name, an entry, and then a record number. Now, the biggest reason that we have a record number in this case is that we want to be able to order our queries correctly. So we can use the record number in order to order our queries so that we get things in the same order they were in the original file. Now, chances are it would come out this way anyway, but as database rows do not have a natural order to them, we want to enforce this, and just in case. So I'll start by doing a select distinct on the log file name from logs, and this should tell me here are all of the log files that I captured. So I see BTMP, which is used to record unsuccessful logins, LightDM, Mode Manager cups, rsyslog, etc. Check root under fscheck, check fs. So there are a whole bunch of things. udev, if I want to see what kind of devices have been installed, and authlog, etc. So let's start with something really basic. Let's have a look at dmessage. So dmessage will just tell us about devices on the system. Now we think this was a remote compromise, so this wouldn't be necessarily interesting, but we're going to look at it nonetheless. So we're going to select log entry from logs where log file name is like %, which is the wildcard in SQL, dmessage %, and we will order by recno. And we see we got 508 rows. Now I could easily capture this to a file if I wanted to do so, and that might be easier. If you'll forgive me, I will temporarily reduce my font. So here you can see these entries. Now these entries are done and they have a timestamp from when the system was booted. So here I have my various entries. And you can see, as we suspected, nothing terribly interesting in that particular file. What about some of these other files? Dmessage wasn't interesting. syslog, possibly. What about authlog? Let's have a look at that one. So I'm going to do the same kind of a query, except I'm going to say it is auth. So %auth %. And once again, what do I see? Let's see if in particular I see anything relative to Jan, or root. And here I say session open for user root by John. And this was on March 9th. Again, March 5th and March 9th both seem to be important days. And we're executing a command here. Listening on port 22, which is normal. This is abnormal. Why does the user LightDM have a new session? Again, that user doesn't normally log in. So let's see if there's anything else that's interesting. Let's scroll back to the 5th. And we'll have a look. And actually, I don't have logs back to the 5th in this particular file. That might be in an archived file, which is something I could look at if I thought it was interesting. So this one seems to start on the 9th. Someone disconnected. Failed password for this user, and sure enough, it was LightDM shortly thereafter. So let's see, this is 21:33:55 at 21:34:00. So 5 seconds later, it was accepted. So someone fat-fingered the password for LightDM. Again, this LightDM user shouldn't even be logging in. A session was opened for that user, and they disconnected a little bit later. So this is probably just a test. And what happened right after that? Sure enough, user John with 2 ends connected. Now all of these are coming in with this IP address just because it's in a virtual box, and that's the only machine that has connectivity into the system. And what else happened? It looks like this user John with 2 ends logged in, and he tried to do sudo, and it said he's not in the file. You know, you always get that message, this incident will be recorded. Well, apparently this is where it's getting recorded. He then disconnected. There were a few interesting items, and again, we're just adding a little bit of evidence here and a little bit of evidence there to paint our overall picture. You know, there are a whole bunch of other files in here. We could look at the system logs. Those tend to get a little cluttered. Fail log. So we see just from looking at a few logs that capturing these logs can be useful. We're not necessarily going to examine all of them, but as you go through an investigation, you might find certain logs that seem to be relevant, and you might want to do some work with those. Well, that's all for this video. As always, if you're enjoying these videos here at Pen Tester Academy, tell a friend, help us spread the word. We'll see you soon. Hello everyone, and welcome to Linux Forensics here at Pen Tester Academy. In this video, we're going to look at login attempts. So we're going to look at 2 files in particular, and these 2 files are in the log directory, and one of them will give you everyone's login information. In other words, when did this user log in last? The other one will give you failed login attempts. So if you go to any Linux system, you can go to a terminal and you can type last, and it will give you a list of when people have been on the system. And there are some additional parameters that you can give to last, such as -F for a full listing. You can give it a command like I for IP addresses, and you can give it AI in order to append that to the end for remote logins. And you can give it the wide format, and you can give it some extra things, such as when someone changed the run level. If you do that, you see that you get a little bit more information. And of course, that's what we're going to do on our image that we've mounted. So let's go ahead and go back to our script. So my script starts out just like most scripts that I would have, with shebang, bin bash, I have a usage statement that says this will take your mount point for your subject media, optionally a database name, and it will give you a log of successful and unsuccessful logins. And you might optionally store this in a database. So if you don't give me enough parameters, I call usage, and here I will create a file, a CSV file again, although it's really semicolon separated, and I'm going to put it in my temp directory. I'm also going to put it out to the screen. So I start out with an echo of my header. Who or what is the first field. The terminal or an event, if it's not a who, if it was a what in the first column. A start time and date. A stop timestamp, elapsed time, and an IP address. And all of that is going to go to the screen and also to this temp file. Here's my last command, -AI. Please append information to the end, and I would like the IP address. Here is my full listing, WX. It's giving me everything, and here is a file. So last will optionally take a file instead of the standard one. So this allows you to run last on the image. $1 was the path to the root directory, and it's looking at var log wtemp. It pipes that to my awk command. So what does this awk command do? This awk command uses substring in order to create a CSV file from our fixed length file. So if you look at the results from last, everything appears in a fixed column, and this is just a set of substring commands that are put to awk in order to bust that up into fields. I then pipe that to another sed command, and this sed command is used to get rid of spaces before a semicolon. So if I have 0 or more spaces before a semicolon, I replace that with just a semicolon globally. That means if it happens more than once on a line, please do it again. And I also get rid of any trailing spaces before the new line using something very similar. If there are spaces before the new line, substitute just a new line, please. I then pipe that to my T command. Here again, because I'm appending, I use a T-A. If I didn't use the -A, I would lose the header that I created up here. I send that to login CSV, and then I do the exact same thing, but this time for login fails. Now, because it's login fails, I use the last B command, and it's on a slightly different file. It's under btemp. Everything else is the same. As I've done before, I say if you gave me more than one parameter, then first of all, change ownership of these two files in order to make MySQL happy. I use my cat less than EOF construct to pipe everything from this line to the EOF into MySQL. So what are those things? Well, I first create a logins table with the who or what field followed by the terminal if it's a who, or event if it's a what, a start date, a start time, a lapse time. I just store this as a string because you're not really going to necessarily search on that. And it's fairly complicated to convert that one because of how it's displayed. And then an IP address. And I create a primary key that's a big int called recno that is auto-incremented. And here I load it into my file. So loading it into my file is a little bit complicated, but it's not too bad really. We've done similar things before. So I call load data in file, temp logins.csv into table logins. Fields are terminated by semicolons. All this stuff is standard. I say ignore one rows because I have a header. Here I say who or what, etc. And the only thing that causes me grief are the date times in my table. How do I deal with that? I set the start date time to string to date. Now, string to date has a misleading name because this will actually return a date time and not just a date. That is, if I have in fact given it time information as well as a date, it will create a date time. So I give it the day of the week, the month, the abbreviation of it, the day in the month, hours in military time, minutes, seconds, and then a 4-digit date. That is the format that this is displayed. And I do the exact same thing for stop, and that should import my information. Here I have create table login fails. That is the exact same kind of a table. It's just for failed logins, and the format is the same here. So this is essentially repeated. Here's the end of my SQL statement, and here is the end of my if. So I'm going to run getlogins.sh on media part 0, and I'm going to connect to database case 2015-39. I'll let this run. It does its thing, and then it asks me for my database password. I give it to it. Boom, it's done. If I go to my database, do a show tables, I will see a couple of new tables. I now have login fails and logins. So if I do a quick select from login fails, I will see that in fact I recorded my login failure on March 9th for the user LightDM. Well, that's all for this video. As always, if you're enjoying these videos here at Pentester Academy, please tell a friend. We'll see you soon. Hello everyone, and welcome to Linux Forensics here at Pentester Academy. In this video, we're going to look a little bit more at those logins and login fails. So in a previous video, we extracted that information from our image, and we had done a very basic query, and we had seen that in fact there was a failed login. Now, by the way, there are a couple of bad rows, if you will, in this database. This is because there was an empty line and then another status message that came across. And it's one of those things where, sometimes you can work and get something exactly perfect, or you can say, I just want to get the information. And I realize that these are two bogus entries. They don't have any information in there. So do you waste your time perfecting your scripts so that this goes away, or do you just ignore it? And I choose to just ignore things like this. So we said that sure enough, LightDM had a failed login, but let's look at the successful logins. So if I have a look here at my tables, so again, if I do a show tables, I see that I have a logins table, and if I describe it, DSC logins, it tells me it's got who or what, terminal or event, start, stop, elapsed, IP address, and then a record number. So I just want to know who or what, and the terminal or event, start time, stop time. I don't really care about elapsed time. I can calculate that myself. And the IP, and I want to select this from logins, and I would like to order this by recno. Again, I want to preserve the order of these records. So when I do this, I get 74 rows. So let's see what's happening here. Now, notice that in this log, as in many logs that you might look at, newer times are at the top. So we can start at the bottom, and the system was booted on the 5th. All right, so John logged in shortly after that. System was shut down. Now, of course, a lot of this is because this was run in a virtual machine. So I can see people logging in, shutting down. Let's have a look at what's going on around the 9th. So here we start on the 9th. System was booted. The run level was set. And John logged on from $0, which basically means he was on at the command line. And a little later, this John with 2 N's was on, as was LightDM. And we already said that LightDM shouldn't be logging on. The system was rebooted not too long after that. And it looks like John logged on again. Now let's see. Were there any other interesting events when it comes to logins? And I would say, based on what I see here, not really. So again, we're just slowly adding more and more evidence to paint the picture of what occurred with the system. So in this case, it looks like we saw the failed login attempt, and we can see some logins by people who shouldn't be logging in, but nothing else terribly useful is coming out of this particular file. Well, that's all for this video. As always, if you're enjoying these videos here at Pen Tester Academy, tell a friend, help us spread the word. We'll talk to you soon.